Cindy Kelly. It is Wednesday, April 25th, 2018, and I have with me a scientist who is working in the Computing and Computational Sciences Directorate. And my first question to him is to say his name and spell it.
My name is Budhu Bhaduri, spelled B-U-D-H-U, and last name spelled B-H-A-D-U-R-I.
Thank you. My first question is to tell us something about yourself. Where were you born? What was your childhood? How did you become interested in becoming a scientist?
So I was born and raised in a small city in the eastern part of India called Calcutta. And I always get that reaction because people feel that it's really, really large. It's a lot of people, but it's geographically speaking, it's very, very small. And that's my area of research. So I always like to point out that the distance dimensions are very relative of how we think what is small versus what is big. There are a lot of people and a lot of concrete and asphalt, but the space is quite restricted. People are packed in. So I came to the United States in 1992 to pursue graduate school, particularly motivated to do something pursuing the environmental and applied research. I was always inclined to science. I liked science and when I was going through school. And then I remember distinctly on a Sunday afternoon, they used to have a 1-hour program on National Geographic every Sunday afternoon. And I was sort of hooked to that one. And there was this particular one that talked about cleaning up streams in Germany that somehow stuck to me. And it was one of those first big push in the sail in that direction, saying, I would like to be part of something like that. Making a difference for the planet. So that's how I got into science. I studied geology in college, and as I always tell people that I started at the center of the Earth, and then it started floating upward. So as I went through grad school, I started floating up and up and up, and then in graduate school, I started doing urban hydrology, so I was looking at streams. And then for my doctoral work, I started looking at satellite images and how those satellite images start telling us things about the planet. So I went all the way from the core to space, and I think that's where I had to stop and start working. And so I came to Oak Ridge after graduate school back in 1998 with a plan of working here for 2 years and then going somewhere else. And I will have to admit that it's still that plan, a 2-year plan. I'm just terrible at executing it. I guess when you're having this much fun, you just don't have enough time to execute your 2-year exit from Oak Ridge. So one of these days.
That's great. Well, tell us, what's been so much fun? What have you been working on?
So I came and joined this group that is called the Geographic Information Science and Technology. And today it's mainstream societal technology that everybody carries in their phone, particularly the GPS and navigation and maps. But if you look back, the group had the word geographic data in its name back in as early as 1972, which is pretty pioneering. So I had a curiosity about learning that why does a national laboratory that has been set to pursue nuclear science and engineering do geography. What we found out is that during the Manhattan Project, there needed to be a way to disguise the location of where these 3 plants were. So when you look at the old maps of the reservation, you will always find that they had a tilted north arrow, which is unacceptable in geographic or cartographic research, that north arrow is always straight pointing up. And the reason is that all the 3 sites, Y12, K25, and X10 at that time, they had their own projection or coordinate systems. So if you did not know the magic conversion, even if you had the map, you could not actually get the latitude and longitude of this place. So that's how people were brought in to create what I call geographic data in disguise. So That was one of the defense or security mechanisms. One of the work that the group has done very successfully over the last 3 decades, starting last 3 decades, is we are uniquely recognized across the world for our work in understanding global population distribution and dynamics. So where do people live, and where, how people move on the landscape for a variety of reasons, after disasters, for geopolitical unrest, and even things like transportation on a daily scale, how people move within a city, because the movement of people actually drives our need for energy. If we didn't move, or if everybody stayed home, we will not have these societal challenges like congestion and pollution, and so life would be very simple, but we move. So understanding those, but historically, the reason Oak Ridge became a focal point of population research is because of a requirement from the Nuclear Regulatory Commission that stipulates all facilities with nuclear material to understand on the decadal census years how many people live within 50 miles of these facilities, so across the nation. And anywhere you have a nuclear reactor, for example, in universities, they have to do this as well. So when we did not have geographic information systems or software that allows us to do this almost on our phone today, it was a big scientific experiment. So people had to get a lot of data together and come up with a map that showed where people lived or how many people might be. So this was done usually through census data. And from that type of research, eventually it turned out that we could actually understand a lot about how this planet is populated. It's very interesting problem because and it provides a sort of the backdrop of why satellites became so important. If you think about the world's 7.5 billion people, and you make families of 4, which is about a standard assumption of a household, 2 parents and 2 kids, and give each family about 1/4 of an acre, which is quite a bit of space in the global standard. You can fit every family in Alaska and still have 10,000 square miles left. If you give each family about 1/8 of an acre, which is still little over 5,000 square feet, which is pretty luxurious space in the global standard, you can still fit everybody in Texas and Oklahoma, and without stacking people up. So the challenge is that there is enough space on this planet, and people are not concentrated, so they're distributed. So you're really, when you're trying to understand where people are, it's really looking for a needle in a haystack, because only 2 to 3% of the land surface is actually populated by humans. So the amazing thing that we found out is that when you have satellites and they're taking pictures, and they're taking pictures all the time at unprecedented frequency, you can see a lot. You can see a lot much better. So now we have pictures that are a meter or 1/2 meter resolution. So you can see very detailed features on this landscape. Finding those is a very important scientific challenge, and that's where the computers came in. That if you have to look at, it's a task that humans cannot perform by just using eyeballs. So if you think about a 1 meter resolution pictures of the 48 states, that's about 10 trillion pixels. So if you had humans go through 10 trillion pixels looking for where there is a structure, it is almost impossible. So that's where computing comes in, that you want to take advantage of the big, large computers that are very good at sifting through data, and you use scientific techniques like machine learning, artificial intelligence, deep learning to find, let the machines find this human-built structure, right? So nature never builds a building. If you see a building anywhere, you know that some humans must have been there. So we are using those structures as proxy for the human presence. And the amazing thing that has happened is, as we are trying to look across the planet, especially in the global south of the equator, places like Africa, sub-Saharan Africa, in the southeast, the regions of Afghanistan, Pakistan, Kyrgyzstan, that entire region, we do not really know where people are there because those official censuses have not happened. So let's take Afghanistan as an example. The last official census in Afghanistan was 1979. So it's been a long time since then, and we don't really have a good understanding of where people are and how many people might be in Afghanistan. Nigeria is the same example where the last official census was in 2006. The last official estimate was 2012. And about 4 years back, I had an opportunity to intersect a group from the Bill and Melinda Gates Foundation, and they are interested in eradicating polio, or that's their mission, to eradicate polio. The task is fairly simple at one level, which is find every child who is between 0 and 5 years old and give them the vaccine. But when you have your last official estimate done in 2012, the people you are trying to find do not exist in a database, right? So the only way you can find them is when you can find each and every settlement or individual structures and huts in Nigeria. So we started working with them, and we are building a bottom-up estimate of Nigerian population, and a lot of countries for that matter. In Afghanistan is one of them. So I call it this amazing achievement of finding the missing millions, right? So these people have never existed for our civilization, which is remarkable. So as human beings living on this planet, we have a moral and ethical almost responsibility to make sure that we find them and we ensure their well-being, right? So the human security and the quality of life. It all goes back to what you first started saying, is that these sort of Manhattan project scale investments, as they have come through decades, how they are making an impact today for society. And we would not be here unless we had to first look for people within 50 miles of every nuclear operations to ensure their safety. We are even doing interesting research. For example, if you wanted to create nuclear power plants for the future, you have to ensure that you find places on the planet or even in the nation where you can safely create a nuclear plant, which means you have to know where people will be in 2030 or 2050. So one of the science projects that we have done is to understand that if things worked just like they have worked for the last 30 years in the 48 states, where will people be and how many people will be there in year 2030 and 2050? So you have you can plan ahead of understanding where, how feasible it is. And this has impact in many of our nation's security. If you know the airports, where they are, they're all getting surrounded by residential developments, and that has a huge impact in terms of noise pollution and abatement, right? So knowing where people are. One of the key research that we do in population dynamics at Oak Ridge is understanding where people are when they are not sleeping at home, which is the census reports to us. And if you look at that, that's only 1/3 of the 24-hour cycle, right? So maybe 8 hours we are sleeping at home. The rest of the time we are somewhere else. So knowing and understanding and documenting, creating data sets that tell us where people actually are during those other 16 hours of the day allows us to better understand what kind of environmental conditions they are exposed to. Is there any, what type of services do they need to make their lives better? Do they have access to jobs and health care? And it all goes back down to where people are. If we don't have to worry about people, we won't be doing any research, right? So at the end, our whole research enterprise is trying to make humanity better, trying to make the quality of life better, and not just for the United States, but we want to have a global impact. So that's the fun part that has kept me here for 20 years.
Oh my goodness. Well, it's incredibly challenging.
It is.
It must be.
It is.
Do you work with sociologists and anthropologists and historians? I mean, this is, the
Um,
migration of people is very complex.
So I work with a very interdisciplinary group of people, scientists who have expertise all the way from social science, for example, geography, anthropology, all the way to people who work with very large computers, a lot of data, like electrical engineers, computer scientists, computer engineers, civil engineers, transportation engineers, because unless you bring a very interdisciplinary approach, some of these societal challenges are impossible to solve. So if you just had a machine who could look at images, you will not understand, why people do what people do. So explaining why people are where is an important part of it. So yes, we have to constantly work with an interdisciplinary group of experts.
I think it's Thomas Friedman who talks about the greatest migration that's happened in the last 10 years from, just take China and its migration from rural areas to the cities. I mean, are these the kinds of things you've been?
Yeah, so that's a very important trend that we are very aware of. We know that people cities act like magnet. So for the last 4 years, I have been directing an institute at Oak Ridge National Laboratory called the Urban Dynamics Institute. And we are looking at this global phenomena of population and land use, water and energy, sustainable mobility, and then urban resiliency. From the perspective of data and computing, what sort of insights can we bring out? And one of these trends that we can now very well observe and monitor across the planet is this urban migration. Eventually, you want to know how the planet is doing, right? Today, you can wake up in the morning and take out your phone and immediately see what's outside, or how hot it is outside, or is it raining outside. So you know what's happening in your immediate vicinity. But wouldn't it be nice to know that, what is the pulse of the planet today? Like if I split the planet in 1 kilometer cells, I would like to know the health of the planet today. What's happening in every one of those 1 square kilometer areas? Are there shortage of water? Are there excess of water? Is there flooding going on? Is there a drought going on? So that type of information flow, we can clearly think about getting towards, because we now have this incredible amount of data flow from satellites, from sensors that are out there, and then we also have access to these large computers that can allow us to take all these data streams together and then help us create models that generates information that we use, right? My best or most favorite example is the weather app. There are 2 apps on our phones that have truly attained, in my view, a globally pervasive status. One is the navigation. So we all have an application that tells us if I wanted to go from one place to the other, how do I go there, how the traffic might be. And the second one is weather, right? And if you think about that weather app, it gives you a number and an icon that either shows the moon or the sun and a little bit of cloud and the rain, right? But if you really think through hard, saying, how did I get that number? It starts with a lot of satellites collecting a lot of data that gets integrated by scientists and processed through very large computers. And then at the end, all you see on your phone is a number and a picture. And we are making life-changing decisions or life-dictating decisions based upon that. But we often forget that how robust and pervasive science that is standing behind to get us that service, right? So there should be many, many more of these kinds. As I talk to my colleagues, I find out that they would like us to know what the water quality is. So just if you drank water today, did you check your phone to see how the water quality is in the tap of Oak Ridge, Tennessee? I'm sure a lot of people worry about it. We all worry about water or the air. So information makes us live a better life. That's, I think, the interesting but challenging part is how do you make all those things come together and create these benefits for the better, bigger social good.
Well, you're making me think about a lot of things. What about the trend that's been predicted that the seas will rise and the coastal areas, which have been the most attractive for people to live in, may become flooded? And has your group or others taken your data to kind of analyze what's going to happen in the next?
So all we know that there is a clear trend that in some parts of the world the sea level is clearly rising. There are coastal areas that are getting inundated, so there is a displacement of people. And we know that from a fact of, when you have a devastating flood, it brings displacement of people every year. Like, think about the 2017 hurricane season, what happened in Houston. You will always have displacement of people from flood. So I think where we are not quite mature is to understand exactly where those people will end up going. Are they going to just move a little farther inland, or they will take a longer migration to go back to other places? And I think the social scientists are clearly interested. My social science colleagues are clearly interested in that phenomena. Collecting those kinds of data sets are not an easy way of doing it. A lot of the data that gets reported is because of the popular press. So anytime you have a hurricane and people are moving, you find out how many people lost their homes, and how many people had to be relocated in Colorado. But as time goes and the newsworthiness of that event sort of dissipates, you don't really quite hear the news saying so many people moved back to New Orleans from Colorado, because that's not quite a interesting news to report. So these kinds of data sets, quickly get out of the public space, and we don't have a very good way of going and grabbing those things to really understand the nature of the migrations. And there's quite a few researchers who are trying to understand and collect data, but not at a global scale that we would like. So observation-based understanding from data is one way of getting towards that answer. So if you see refugee camps popping up somewhere, or informal settlements popping up and the fringes of the cities, those people must be coming from somewhere there if they're not. And that's how usually the developments work. Like, your people come in and they... so it's a matter of equating. Can you connect the dots and actually understand which areas are people migrating out of and which area they are likely to go? But it's a very complex social phenomena that there is not just a very simple thing that you can look at and say, there are lots of informal settlements in very large cities. If you go to Southeast Asia, you can see a lot of them, and they absorb a lot of these refugees. So without building new structures, so you will not always see a one-to-one correspondence of people being displaced and homes being built, because they will just go in and increase the population density of those areas. But it's one way of looking at it, what you can see from happening on the surface of the planet.
So do governments sort of try to reach out to you and learn what you have learned about their cities or their migration patterns in their countries?
So I think our job is to help. So we worked with the educational research community and also the federal government, the U.S. federal government, and agencies that work internationally. And I think where we are making the biggest difference is to telling them where people are and what sort of conditions these people are living in. So many developing nations have initiatives to improve the quality of life of people they feel that are living in slums, which is a very crude way of describing people living in informal settlements without having access to a lot of the societal services. Because what we might call slums in the United States will look like palaces in some other country. So it's a relative description. But a lot of these countries don't even know how much slum areas do they have and how many people live in these slums, right? So if you do not know, so in our science, we call it the basement problem. That means you do not even know the denominator. So you may have $100 million to improve the quality of life of people, but if you do not know how many people, you cannot start any plans, right? So it's a fundamental, foundational data that you need to first get before you can make the first ever progress or take the first step. So we are helping organizations understand where these sort of people are, and do you take services back out to them, or what would be the best way to serve these people with the societal services that they may be entitled to from their governments.
Well, it's immensely complex and very important work that you're doing. Thinking about the immigration problem, from the Middle East to Europe, and how the factors have changed radically in the last 5 years, with the nation states being welcoming and then now not so welcoming, and now putting pressure on the states in which these people are leaving from to block even their passage across the ocean. I mean, it's just
it is complex, and so humans as a species have clearly demonstrated an affinity, a trend, and a commitment to move from the day we came on this planet, right? And the question is why, and there could be many explanations of why humans try to move. But we have moved across the planet, and we have gone from East Africa. Now we populate most of the landmass in this planet, and some of which is natural and some of which is not. Some of which has come from policies that nations have taken. We have created countries. We have created divides. Nations have created divides by their own. So the number of countries keep going up as we divide, and that creates internal migration. If you look at the Indian subcontinent, those 3 countries is an outcome of a political settlement that the British had with the Indian government. If you look at Sudan and South Sudan, that's an internal agreement that they agreed to create 2 countries out of 1. And I don't see this stopping. That's just, if you believe in the human history, these kinds of phenomena is only going to be observed over and over and over. I think what's more interesting is that the mobility has gone up, right? So accessibility to place is clearly is easier. There is a recent Nature paper by some researchers at Oxford and Google that shows that about 80+% of the human population are within 2 hours of a city of 50,000 people, right? So the accessibility has gone quite a bit. The revolution that we are seeing in urban cyber infrastructure is also very interesting. So if you think about our research, we have always created this broad divide between who's urban and who's rural. And if you ask people that what's the underlying assumption, it is essentially population density, right? So you take a small city or small place like Cleveland, Tennessee, which is city by a legal definition because they're incorporated. It's about 40,000 people. but they have faster internet than anybody on this planet. So they can stream movies than you and I. They can order commodities from the internet shopping platforms and get it delivered at the same time. So are they any less urban than people who live in a big city? So these sort of definitions are changing. So the quality of life is changing in other different ways, and which is, again, brings it to the point of what is the role of computing as a field, which includes, cyber and cybersecurity, in impacting human quality of life, right? So we are almost, in some ways, we are changing what definition of what's urban versus what's rural, right? Those are sort of, we are blurring that, which science should do, right? Science should change the way we think about our surroundings. That's the ultimate success of science, if we can make this positive impact on humankind.
Is your team well supported? Is it growing? Is it?
Our team is growing. This is sort of a new area of research that has emerged, and 15, 20 years back, if you asked people to think if they could get directions on their phones or open up their browser and look at any place on Earth of what it looks like through a mapping interface like Google Earth or Bing Maps from Microsoft, that would have sounded like science fiction, right? There is. I always like to remind people the story about how geographic data has given birth to computing, and maybe it's relevant in this context. So the first census was in the U.S. was back in 1890, and the mechanism was marshals and horsebacks went around the country and counted people, and they would come back, tally the numbers, and increasingly, if you look at the trend in census, the things the kinds of data we started collecting went beyond the basic, how many people and like a gender and age, right? And we wanted to know which religion they followed, what kind of socioeconomic strength they had, and even terms like pauperism, which we don't use anymore, which we call it poverty today. But pauperism is a word that is documented in census that people wanted to know. And the real challenge came in later part of the 20th century, in 1940s, when the estimate was that there has to be 65 million people would be counted in the next census. And what they realized is that if you repeat that process of horseback riders going and counting people, it would take you over 10 years to complete that process. So necessity is the mother of invention. People started looking for other types of data or solutions. And they found this biostatistician in Baltimore, Maryland, who had this technology of very fast counting, right? And that was the punch card counter that was successfully used to count 63.5 million people. And the machine was blamed for the missing 1.5 million. And but between 1911 and 1924, I believe I have to check, but that company was successfully commercialized, and between two mergers, it created IBM. So geographic data drove the birth of computing because you had too much data to crunch. So we are seeing another version of it today with so many satellites out in space who's collecting data. The first census was 1790. So it was 1890, 100 years later, when we had that big challenge, and then 1911 to 1924 when we took the leap of faith with technology and computing. So it took about 100 years to hit that problem space of too many people to count with people on horsebacks. So we are seeing another sort of data revolution, and that would give birth to new generations of computing. It's not hard to understand. We all live this life, so I have the fortunate opportunity to have fun with everyday life, which is pretty unique.
That's wonderful. So would you advise other young people to go into science?
Oh, absolutely. Especially, it's an interesting question. If you think about, the first answer is absolutely. I would like to inspire everybody to be part of science, whether it's physical sciences or social sciences. People should be aspired to become scientists. The interesting thing I will point out, which in my life experience or over my career that I have struggled with, is I have successfully lived a life of a scientist and a researcher in a group that is pursuing research in geographic information science. Although as a nation, we have lumped geography largely into the School of Liberal Arts. So when, having 3 kids going through high school, one is just out and the 2 are still in high school, when I think about their life or what sort of counseling and guidance they get, I don't think they're being told that, you're so good in science, you should go study geography, right? So I think, the time has come when these sort of new scientific areas are emerging and, exciting everybody, right? So how many people do you think are going to give up their navigation app or their weather app or the GPS in their phone, right? So it is a very strong aspect of science, and the next generations, that is also our responsibility as scientists and researchers to inspire and motivate and then grow the next generation of scientists and engineers as part of our workforce. So absolutely, it has to happen.